This conference will now be recorded.
All right, thank you everyone for joining. Happy New Year. When we last left off in December in our last tape durability meeting, we went through the document. We had some great feedback from Ed and team, and as well as Yuichi. And Yuichi has graciously offered to present some of the historical work that Fujifilm has done in tape modeling and durability, and we'll present that today. So I'll turn it over to Yuichi and go from there. Thank you.
All right, thanks. So this is Yuichi, so from Fujifilm. So today I'm going to share our, past experiences with focusing on long-term archival stability. So okay, so do you see my first page showing the, figures, cross-sectional image of tape?
Yes, we do.
Okay, so here is the basic tape components. So we have basically three types of tape components. The first one is, needless to say, magnetic particles. And we also have binder, which is organic material, and it's kind of glue to bond the magnetic particles. And we also have lubricants in order to reduce the friction between tape surface and magnetic tape head. So today, I would like to focus on the stability of magnetic particle. So here is the kind of very basic of magnetic recording. So as you know, data bit is equal to magnetization pattern, which is showing like here. So we have two types of directions of magnetization. Let's say, so if the magnetic particle magnetization is upward, that means 1. And if magnetization is downside, that means 0. This is not the exact right definitions, but it's kind of good to start to understand stability of magnetization. So, which that means any severe demagnetization means uncorrectable error. So please interrupt if you have any questions. So here is the causes of demagnetizations. So we have basically two types of causes. And the first one is thermal energy, and which is equal to temperature. And the second one is oxidization of magnetic particle. And so in terms of oxidization, O2 and H2O, which is humidity in air, is the causes of oxidization. But as described in here, oxidization is no longer a problem thanks to characteristic of barium ferrite particle. Because barium ferrite particles is already oxidized. So that's why after barium ferrite particle, this is no longer a problem. So the only causes that we have to care is thermal energy. Okay. So I'm going to explain the key indicators and some, very basic physics in order to understand the, the stability of magnetization. Here is a key indicator. So indicator is delta E, which is equal to energy gap between upside magnetization and downside magnetization. Here is the kind of images for energy barrier. So if you need to switch magnetization from upside to downside, we need an energy of delta E in order to overcome this potential barrier. Okay. So, and here is the, if thermal energy is comparable to delta E, magnetization will be switched immediately. So thermal energy is equal to kBT. Kb is just a kind of constant, which is a Boltzmann constant, and T is temperature. So kBT is equal to thermal energy. And again, if thermal energy kBT is comparable to this energy gap, magnetization will be switched immediately. Okay, so based on this physics, so thermal stability is equal to delta E over kVT. So based on this indicator, mean time for magnetization reversal is described by this equation. So this is a kind of, lifetime expectation. So here T is the mean time for the magnetization reversal, which is almost equal to the lifetime of magnetization. And T0 here is just a constant. And here is the thermal energy, as I explained before. And this is exponential. So mean time for magnetization reversal is very sensitive to thermal stability factor here. So that's why we have to be very careful these parameters. So in the last conference call, Jason mentioned that, did we consider the, humidity for this magnetization reversal? So I said no, because there is no humidity factor here. So that's why we usually do not take into account humidity effect in terms of magnetization stability.
So Yuichi, you mentioned that it's not, you said temperature is the constant that affects the media with barium ferrite. Are you saying that relative humidity does not affect the particles, or are there other things such as the binder that are problematic with high humidity?
Well, again, relative humidity does not affect the lifetime of magnetization based on this equation, because we only have a temperature here, right? And there's no humidity factor. So that's why. But in terms of, binders and lubricants, humidity may affect the lifetime of, of these stabilities.
Are you aware of any testing that either your company or other companies have done? So if humidity is no longer a factor with barium ferrite, perhaps a test at the high end of the humidity spec for the media and the low end of the temperature spec, based on the equation you just presented, would mean very high media life cycle. media lifetime. Has that been tested and proven?
Well, yes, if we really focusing on only magnetic particle, yeah, we are very confident that any humidity does not affect the lifetime. Yeah, because again, we have very concrete physics for it, and so that's why. But please don't get me wrong. I'm not saying that humidity does not affect the read light performance.
Right.
I mean,
I'm
go
sorry, I
ahead.
didn't mean to interrupt you. Oh, I was just going to say that this is the difference between what we would call media durability and magnetic stability. For example, the Challenger tapes that went down into the ocean and were sat at the bottom of the ocean for 3 or 4 or 6 months or whatever, the magnetic stability of those magnetized particles did not degrade. They were still fine, and even soaked in salt water. But the media itself had degraded, and there was a lot of problems with trying to sort that out. So when I was talking last week about the differentiation between this, we'll call it, do you ever have a magnetic particle that becomes unmagnetized? That's one thing. That's what Yuichi-san is talking about. Versus, would you have problems trying to read a piece of media on a drive? That makes sense?
So Ed, are you referring to the substrate and the binder separate from the actual the particles? Is that what you're trying to differentiate?
Yeah, I'm saying that once you magnetize a barium ferrite particle, for example, the magnetic field in that particle doesn't degrade very easily. And you could soak the cartridge in water and it would be fine from the magnetic particle point of view. In other words, the field doesn't switch like the superparametric limit of disk is happening now. But that doesn't mean you could take that wet media out and run it on a head and be able to recover the data. You wouldn't be able to read the transitions, or the media would gum up or something like that. Now, I'm sorry, Yuichi-san, I didn't mean to interrupt your presentation.
Thank you very much for supporting. Yeah.
And Jason, tying it back to the what were we talking about? The Arrhenius sort of plot stuff, because disk is close to this limit where temperature affects whether the magnetic domain switches. I don't know for facts, but I believe that's why you have, and the fact that the fly height is a function of energy. That's why predicting reliability of disk works for the Arrhenius thing, and why generally it doesn't seem to work for what we're trying to do. At least that's my less, non-PhD physics understanding of it.
I'm trying to piece that together. So the Arrhenius function looks at an energy, and I believe Yuichi is saying that the thermal stability is affected by the thermal energy. So Arrhenius would, I believe, apply if it was just on the particles. And I believe the separation here is now the substrate and the ability of a drive to read it. So I think maybe, Yuichi, I don't know if you go into further details. We should hold other questions until further on in your presentation if you address any of this.
No, I'm sorry. I was very focusing on the just magnetization stability. So,
and I think you're right, Jason, that theoretically the stability of the magnetic particles in tape are a function of temperature. So you could do an Arrhenius plot thing, Arrhenius analysis, and what is the reaction rate as a function of energy? But that is a much higher temperature than the operating condition we're talking about. So I don't know what it is, but Yuichi-san, at what temperature would a barium ferrite particle demagnetize, or the energy switch?
Well, I would say it's very, really high. So can I proceed to the next slide?
Yeah.
In order to,
I think it's just really high compared to operating temperatures. That's what I was trying to say.
Yeah, so here I wanted to explain, so how do we measure the thermal stability? So here is the challenge we have, and so measure this is kind of methodology, and measuring magnetization for a few days is just change in magnetization may be undetectable. So the next idea is to measure magnetization for over 10 years, and this is, needless to say, unrealistic. So here is the answer to Edo's question, I think. So measure magnetization under very high temperature with using Arrhenius plot. But even if we employ 100 degrees C, acceleration rate may not be sufficient. I mean, so here is the acceleration factor over room temperature, 27 degrees C. So what I wanted to say here is even if we employ 100 degrees C, so in terms of magnetic particle, it's just, acceleration rate is just 1.24. It's very small. So I mean, 100 degrees C may not be enough to switch the magnetization of barium ferrite particle.
Do you have any historical studies or testing that is, you mentioned that it's not feasible to run it for 10 years, but have other studies attempted to have some number of year process?
Yes. So let me go through my presentation. I'm going to share our past experiences and data, I think. So I think in order to answer to Jason's question, I think this one is appropriate, I think. So not only we measure the thermal stability of magnetic particle, we also estimate the actual signal quality after decades based on extrapolation of the signal decay. So here is the equipment that we have been using, and this is called open loop tester. And here we have tape loop here, and the length of tape loop is almost 1 meter. And we also have speed control here, and at the bottom we have tension control here. So in this equipment, tape loop is constantly running to one direction in order to simulate tape drive and read write running. So in addition, we also have the actual read write head here. And in this test, we write data once and read continuously data. So, and measure the signal quality and measure signal decay. And we also measure bit error rate. Okay. So we, here is the already published data, which is entitled Effect of Thermal Conditions on Bit Error Rate for barium ferrite particle media. So in this test, we employed 65 degrees C and write 500 kbpi data and constantly measure the trend of bit error rate under this very high temperature. And we could demonstrate that there is no significant degradation in bit error rate. So if you are interested in detailed procedures, please go to this website, and hopefully that helps for your better understanding.
And Yuichi, will you be able to share the presentation afterwards so that people have access to the link?
Sure, I'm going to share this link. Yeah.
Excellent.
So here is a kind of summary. So as explained, we have been relying on physics, which enables us to extrapolate degradation of tape media components. So for magnetic particle, we rely on physics of magnetism, and also it provides causes of demagnetization and key indicators to monitor and how temperature affect the reversal time, which is equal to the lifetime of magnetic particle. So I think that's it. So any questions or comments? I hope I could answer to Jason's question.
I think this answers some of it. Oh, someone else?
Sorry. So quick question. Thank you, Gucci, for sharing the study. So one question, so did you also have any data with the humidity in there? So this shows like temperature as a factor affecting the magnetization. Is there any study with the humidity also similar?
Well, I think so, but again, so let me check that. We have kind of data to share with you guys, but again, the reason why we are not focusing on humidity is that we rely on physics, magnetic physics here. So as I repeated many times, so this equation is we rely on, and there is no humidity factors. So that's why. And in terms of humidity, as explained, oxidization used to be a concern for us, but this is no longer a problem thanks to barium ferrite, because barium ferrite is already oxidized at the initial, from the initial. So. Yeah, but let me double check that. I think I could share. There should be something that I should share.
So maybe we can ask the question a little bit differently. So several of us in the call, we've certainly seen some challenges with high humidity. So maybe we break that into two separate paths. One may be the operational ability to read media. And I think, as you and Ed both said, that if the particles are stable, there's something else that may cause challenges with humidity, whether that's the binders, the lubricants, something in the drive. So that would be the more operational. But if there's a second path, which is the simple ability of a media to retain the bits. So if I'm hearing you correctly, if we were to take media, control the temperature and allow it to go to the high end of the humidity spectrum and keep it that way for 10 years, bring the media back into whatever the operational environment is, you were saying that the media itself would not be affected from the humidity from a magnetic standpoint. But I think what Sumit and I are asking about is, what about all the other attributes of the tape media itself? Like, how do we get to the bottom of that, both from the storage as well as the operational side? I think those are our biggest concerns and the reason for starting this conversation here. So I think you've addressed a piece of it, and I'm hoping, how do we answer the other piece of it?
This is Ed. So I like the idea of categorizing because I think it helps us discuss the same problem, if you will. And like you said, Uichi-san just talked about magnetic domain stability. The thing you mentioned, for example, of high humidity and maybe high temperature sitting in some condition for 10 years, and then you bring it back within the operating space. Just as an example, in that case, you would likely not have a media debris problem. In other words, you've only written the tape once. You've only done it at a condition in which the debris does not form. Let's just assume that's correct. In other words, it's within a good space. But you could have a dimensional stability issue with the media. So when you talk about readability, that's where you get into, well, there's different variables there. One is the media could change shape, and that becomes I can't read the data point of view. Or you can be operating it at a certain condition that it kills the drive. And that's, I think, was my to-do, which I didn't do this time. When we talked last time, was trying to get into a categorization of types of failures.
Mm-hmm.
So I think, at least speaking from the Microsoft standpoint, we care more about the media as a whole than the system as a whole, if we take those two elements. So the media for us is a black box, right? So the magnetic particles are coated onto the substrate, but you mentioned it could be the stability of the substrate itself, could be things in the binders. So for us, even if the particles are still stable, our readability may be affected. I think that's
right.
What our goal with this testing was. So how do we pull all of it together to answer that black box question where it's a tape? Can we read
right.
it? And how do we know what bounds that is readable and then at what bounds that it is capable, at least in our case, we're interested in the 10-year mark, and others may have different requirements.
Mm-hmm. And in fact, one of the failure modes historically, which I believe Samit, you guys brought it up with me, but one of you brought it up, was there were papers from the 80s and 90s where after 10 years, the binders holding the media particles together were degrading, as an example. So for the things like media stability, chemical stability, binder stability, those will tend to lend themselves to the kind of things that Uichi-san went through, where the media companies can say, I can do acceleration tests to show that the binder's stable over a long period of time and all that kind of stuff. For the types of problems, let's call it dimensional stability of media, there are methods, and IBM has shared that with some of you on how that can be assessed and projected. And that's something I think is manageable. The problem I always get impaled upon is the idea of things that are related to the head tape interface and generation of debris, generation of things which would cause the drive to be able to unable to read a piece of media. Those are the things that we talked about that take a long time to measure, and unless we figure out how to get an acceleration test going on them, how we can project them quicker, I think we're going to be stuck on those. You know what I mean? Because let's just say that we have 5 samples of media. 3 of them are repeats from a vendor and 2 are repeats from another vendor. And you want to ask your question, are they all the same from a reliability point of view? Right now, the only way we have to answer that is run for months. And if you wanted to then take that and say, I would like to validate that whatever new media I get is good, you can't afford to run every lot for 3 or 4 or 5 months to validate it's good before you take it. I think that's a fundamental problem that we're stuck on here, at least from my opinion.
Yeah, and I do agree with you. So that's our struggle as well. So in media development, so we usually make a tons of new chemicals in order to achieve basically higher recording density. So our struggle is how we're gonna assess the actual lifetime of each tape media. So let's say, so if we make 5 samples, and if one tape is okay at very low humidity and low temperature, and if we take another cartridge and put it into very low humidity and low temperature conditions, that may fail. So there is no very concrete physics to predict media lifetime. So that's why I was very particular about physics that enables us to extrapolate the lifetime of tape media. So all we had to do was, using very harsh environment, which is the like 4-corner testing. So high humidity and high temperature, something like that, and just run tape media with using tape media drive and measure the actual performance.
And there have been, I'm sorry, I didn't mean to interrupt you, Ichi-san.
Yeah, I just wanted to say that's my struggle.
Yeah, and Jason and Samet and the others, there have been attempts to accelerate or predict well, let me use the word runnability of media in a drive, as just to define that as, can you run it back and forth without it starting to chew up something or degrade? And that's a very general term, but I'll use the word runnability. When we started LTO back in the late 1990s, there were tests that we defined, and they're probably still in the spec. I don't know, actually. I haven't looked forever. Like there was a mag coat pull-off test, because at some point we had magnetic coats delaminating from tape. And so somebody defined a test where they glued a test specimen of a certain size on a certain piece of media, and if you pulled it tangentially, you should get X force. That was an example of a trial to accelerate runnability evaluations. There are standard abrasivity tests where you run it over a certain alpha sil material bar at a certain angle and all this kind of stuff to try to predict how abrasive media is. The net of those attempts they may have felt good when we put them into place, but we have proven since that they're not a good predictor of how media actually runs in the drive. And so we're still struggling on what should be the new test, if you will, that might help us here.
And do you think, so one of the proposals we had in the document was a dynamic test, something that would either mimic the extremes in some of our data centers, which would be temperature and humidity variations across the board, compared to a traditional data center that may hold in a tighter range. Do you think a test like that would give us any more insights onto media durability?
Perhaps, I don't know. So this is where you get into, this is a materials tribology egghead doctorate sort of thing. Because, for example, let's just take things we understand, tire wear. You drive around on a road and the tires wear at a certain rate, and we all accept that a very smooth road and rough roads might wear the tire differently. But generally speaking, you have to drive 50,000 miles to figure out what the wear is. It may be true that if you tested instead of at 90 degrees C, you tested at 160, at 90F, you tested at 160 C, you could accelerate that and correlate those two things together. But it may also be true that the rubbers in the tire do not act linear and are not projectable between those two operating points. In other words, there has to be, this is where Yuchi-san, the physics that say, if you do it at this environment, the laws of physics allow me to project what it will look at this environment. And Arrhenius is one of those things for energy-related processes. But to my knowledge, wear-related processes generally don't conform with that. Now, I may be wrong, but that's where I was proposing we need to get somebody who's smarter in that into the party with us to help us understand that.
I'm assuming this isn't the first time that these questions have been asked, so maybe you or someone else on the call is aware of people who started looking at this that would be interested in participating.
Yeah, but from my perspective, it's not the first time. It's just there's never been a successful proposal or idea.
Would you have any recommendations on people that may have considered it in the past that might be interested in revisiting that, or do you think this is something that we would have to attempt anew?
There used to be some magnetic tape institutes like Mint in Alabama, Carnegie Mellon, UCSD, Tulkey, who focused on specifically magnetic media stuff. But I think they are all shut down. I don't know of anybody anymore who actually has an academic look at media. There was a Professor Weick who was doing an academic look at media stability. And, frankly, we are working with him on that aspect. But from a durability, runability, I'm not aware of anybody now. I don't know anybody else on the call who might be, but that was the purpose of bringing it up in this call from my perspective, is to get other people engaged in the thought.
Guessing no takers, nobody else that has some insights?
Yeah, I mean, we don't have definitely the expertise in it, and that's why we want to collaborate and see if anyone in the industry has that kind of experience. Maybe one would be, so what were the different proposals that were made to do? Maybe that something that we should look into, like summarize, so that we don't have repeat efforts and we don't propose the test which have already been proposed before and have proven not so useful.
The two that I was aware of specifically were the abrasivity test, which has not proved to be reliable predictor of abrasivity, and then the physical measurement specs on media, like how can you pull the mag coat off, curl, if you lay a piece of media down, does it lay flat or does it move? There's been specs on that, but we've not been able to correlate that towards runnability either, except in extreme cases. In other words, if you have a really, really stressed piece of media that's all curled up and you try to run it, it doesn't work well. But what we're talking about is much more subtle.
So is there a possibility, like Ed or Yuchi-san, if the experiments needs to be defined, so do we think we have enough know-how to be able to define the experiments to perform this kind of study?
I don't think that we have enough know-how to define an experiment and then prove it works at this point. I mean, our team and my knowledge of what Fujifilm and Sony are doing with us is, here's a test we want to run, and we all just work hard on running those tests. Run it in this environment for, however long, X motion meters, run it in that environment for X motion meters. And if it works, then we deem it good and go forth.
In the last meeting, we talked about the chart that I thought we were going to agree to as far as providing maybe inputs on how often we're at different temperature and humidity set points in our data centers. If you, Sony, and Fuji had similar charts from several different large deployments, would that help modify some of the testing that you're already doing and maybe give us a more representative outcome?
It could. I mean, to me, I look at that right now. Say we're not smart enough to understand the physics or a mechanism that we could figure out how to accelerate. The other path is to collect enough data points with variables and do some big data analysis that might give us insight. I mean, that's kind of how they're trying to solve cancer, right? They're just collecting a lot of data and say, oh, this works, that kind of stuff. So I think that goal definitely has value, to help us learn quicker. Whether it leads us to insight faster, I'm not quite sure, but I think it's worthy of doing, if you will.
So maybe a broader question to Sony, Fuji, and IBM. Are there specific counters and drives, whether it's an enterprise or an LTO drive, that would allow you to get some of that telemetry to maybe help make some of those decisions? Because we've had deployments, either spanning months or years. So maybe there are certain metrics or characteristics that we could do to help you with that data set. You mentioned crunching numbers and looking for patterns. Is there something we can do as a community to give back and help build that model?
Yeah, I mean, I think we could. It's not that complex, really, from that perspective. I mean, on the right side, pretty much just write skips or capacity loss is a very good indicator of how close you are to the edge of margin of the drive success or failure on a particular piece of media. And on the read side, it's just the high level error rate, so which I think is already in what you can already collect. The problem gets into, it's very hard to differentiate between, is that a bad piece of media or a bad drive, looking at any one data point by itself. In other words, even my guys, if they just see it's got this error rate, they can't tell which thing it is unless they run additional tests. But that's where I think in a large data environment where that's what I was calling the high nail strategy, and where there's actually programs in the past who have sold, Crossroads sold something like this, where the most efficient means of finding out which things are tending bad are to look at which things stick up over the norm. That doesn't help you on the projection of how far you are from the end, but it does help you identify goods and bads in your environment. Does that make sense, or am I just...
That makes sense. So maybe in an open forum like this, is it possible for both media providers and drive providers to at least give guidance on metrics that are deemed important, and that we can choose, as each individual company, to provide an aggregate data drop from our infrastructure to you, under NDA. So obviously we don't want to expose some of our metrics, but at least if it's in an open forum that we can talk about what's important, that lets everyone start with a list of characteristics to come back to you with, saying that, all right, you deem these important. Here is a large data set with that data. Does that then help you refine some of the questions you can bring back to this community and potentially make a model? I mean, it sounds like this model is going to be very difficult, if not impossible. Is kind of what I'm hearing based on testing that's been done in the past. But are there steps we can make, at least in the right direction?
Yeah, I think so. I mean, I am in favor of whatever. I mean, I think what's it called in the HCD side, SMART or something like that. They basically have a health monitoring I want to call it protocol, but I'm sure you know much more than I do. But a system of querying the drives or sets of drives.
Yes.
I think we would like to do something similar to that. We want it to be a part of the standard SCSI. You talk to the drive, and here's the data you get. And I'm willing to work with my team to figure out what that should be. The sensitivity points that we always get hung on is we're obviously sensitive about providing something that allows end users to screen drives and say, I want this drive and not that drive. So that's something we have to think through. Because we manufacture to a distribution, and some drives are really, really good, and some drives are at the low end of the distribution. And we are always sensitive about giving an end user tools where they go, here's the distribution. I only want these drives above this point, not that stuff. You understand what I mean?
Absolutely. That's a very fair point and a very fair request. So perhaps we do have a face-to-face meeting for the storage subgroup on the 24th of January, and there will also be a dial-in. I believe all the invites have already been sent out. Is this a time that if we have a breakout session, maybe Fuji, IBM, Sony can at least share proposals of what you would like to see as far as metrics, and maybe give us some insights on why you think that's important? And again, this is really focused on the media durability. So Ed, to address your question, this is not to screen out drives. That is not the intent. So if you were to tell us these are the fields or these are the characteristics we're looking for, and this is why we think it's useful, I think that'll come back to all of us, as well as a larger audience that'll be there in attendance that may be able to provide that. So even members who may not be currently participating in the subgroup may be interested in sharing that data in aggregate with the various companies for the intent of building up some of these modeling and characteristics.
Mm-hmm. And just to clarify, I spoke for IBM. I would assert or assume that media vendors have exactly the same concern that I have from a drive perspective, that you could become smart enough to look at media and screen media, because it's also produced to a distribution. So it's not just a drive concern, I think. I mean, it's really Fuji and Sony to talk about that, but the concept isn't unique to the drive. It's the same for anything that's produced in mass, right? everything can't be made exactly the same. There's always a distribution.
Absolutely. I think we all appreciate that.
Yeah. I'm just trying to be open and share the sensitivities, because if this is going to work, those sensitivities have to be addressed in some way so that we're all comfortable. The other sensitivity we have is that we have experience with a little knowledge equals an explosion of overhead of helping the customer. Just it overwhelms us sometimes with too many things to have to respond to. So that's why I'm interested in packaging it in such a way that it's not a mass of data that's complex, but more a few data points that are most representative of what we're concerned about, if that makes sense.
I think that certainly makes sense. Does anybody else have any insights?
Well, so from tape media through other tape media storage vendor, so I was concerned about how should I say NDA with tape drive vendor. So I believe the only thing we can share is the insights of the magnetic component, the media component, something like, as I said, magnetic particles and binder lubricant. So everything that every data extracted from drive is kind of to share so that's my concern.
Yeah, and that ties back to we don't enable people without an NDA for stuff we think is sensitive, and so the media vendors have to respect the NDA with IBM not to use the tool to collect data that we may consider sensitive.
Right.
I don't know if that's highly strictly legal, but it is the way. It goes both ways. We and the media vendors respect each other's special tools they give us, and don't share that with other people. That's the only way we can work together efficiently, if you will. So I think we can fix that, obviously, but that's where we have to just come up with a set of things that we're comfortable with. But my other bigger problem here, Jason, is that it's really just a data collection exercise that allows us to perhaps measure the health of the system. It hasn't quite gotten to your goal of projecting when something will fail. It might, like we say on big data, if you start seeing these three things happening and the odds are 80% that it will die within X amount of days, even if we don't know why. I mean, I'm hoping it might do something like that, but it's not necessarily a solid projection. It's a path to collect data to see if there is something we can use. Just want to make sure we're in sync on that.
So I think our goal, at least between Microsoft and Facebook, we've talked a lot about what our intentions are. I think our goal is certainly the same. Now, if that's not attainable, but there are ways to work towards that goal, I believe that we are willing to help make that happen. And there are others in the call that may have other insights, that may have differing opinions. So I'd like to give them some opportunities to speak. All right, if no other different opinions. So we certainly understand this may not be an easy end goal, and maybe it's not even feasible. But if we can at least move the bar in the right direction, I think we want to do that. So it sounds like IBM, Fuji, and Sony might need to go off and discuss what the parameters might be, especially ones that may be sensitive that you may not want to expose. How do we reconcile that and come back to us either as an open OCB form, or if you really think that things must be under NDA, then maybe this group isn't the appropriate place to run some of those. How do we bottom out on that?
I think it's up to IBM to make a proposal of what we think would be interesting and reasonable to collect. Maybe that's the best starting point. And if we can't make a compelling argument on why it's worth the effort to do so to whoever's going to collect it, then we fail, if you will, if you think of it that way. And it would be up to IBM to make sure whatever we propose, we have sorted it with the media vendors if we do indeed need some of their special tools or IP to be able to propose what it is. I think that's the kind of cleanest way of getting moving on it, if you will. I'm not thrilled with that idea because I just gave myself another to do, but I don't know. Otherwise, by committee, I'm afraid it would be difficult.
Yeah, I think that's the intent of having this work stream, is that if each of us come to you with very similar requests, both media suppliers as well as IBM, you're fielding many questions that may have 80% overlap. The goal of having this conversation is, even though there may be a lot of work on your team, Ed, for example, at least we can all align ourselves on what those requirements are. So when you come up with that list, you can come up to people on the call as well as other people interested or currently using tape with a consistent, this is what we're looking for and here's why it's important, instead of having 10 versions of that.
Exactly. I mean, I have had this discussion with many of you of what do you need to collect, or, you know, requests for special tools to do something, that kind of stuff. So I definitely agree with what you just said. And that is my goal for participating in this, is to have, you know, to consolidate it into one thread. Now, there might be that one of you guys have unique requirements that drive something else, but I'd like to start with the common thread and then evolve from there if necessary.
Great. So what are the next steps? Do you need some time to go back and think about when you might be prepared to engage either us as a community or individually? What are your thoughts?
I think that we are as smart as we're going to be for a while, so it's not like we need time to go figure out, to develop something. I think we just need to sit down and say, this is what we'd like to try. And I don't even have everything lined up internally. I mean, I'm speaking honestly here. You know, I might get tackled by somebody else saying, no, you can't do that. But that's why I'm proposing that we come back. Now, I like the idea of the next face-to-face, but I'm not sure on the timing of the face-to-face if I'm going to be able to be there. What date is it exactly again? I'm sorry, I don't really.
It is on January 24th, which is a Thursday. It'll be in Fremont, right near San Jose. However, there will also be a dial-in, so no one's required to be there in person. That's certainly optional. Okay, I'll get back to the team or to you on whether or not I will personally be able to be there, but I will be able to dial in regardless. That's my plan. Let's say that's the date by which I will be attempting to make some proposal on the data to collect. Excellent. That sounds great. I think several of us will be there in person. I think it's a good opportunity to get us together as a team so that we have much better attendance than the weekly calls. Yeah. And whether I'll be successful or whether it'll be a dud on what we project, what we propose, I can't predict. But I think this is one of these things where you just have to say we're going to do something on this date, and we'll do our best to see where we get to. Would it be possible to confirm with me by this Friday, yes or no, to at least pencil you in for the 24th so we can put that on the agenda? And if things don't pan out in between, let's say, Friday and the 24th, we can certainly take it off the agenda. But it might help bring some other users that we've been talking to on the side into the fold. Yeah, I can do that. I mean, I just need to get online and look at the calendar to know what the schedules are. There's nothing that I know that I'm waiting for to decide on that. I just don't know. All right. Again, remote attendance is just fine. Yeah. Okay. Excellent. All right. This was excellent. The next call normally would have been next week. I believe we're going to cancel that one in favor of the face-to-face. which would have been the 24th, so 2 weeks and 2 days from now. So anyone else, if there are other topics that you want to bring up now, certainly do that, or reach out to me directly offline, or we will see many or hear many of you on the 24th.
Thank you.
Very much.
All right. Thanks, everyone. Have a great day.
Thank you. Bye-bye.